Hello, good evening, guys. Happy Wednesday. We meet again after a week of break. This is our September week 1. So, how's everyone doing? How was your holiday? I hope it was well. I hope you had a good one. Okay, so right before we begin, guys, I have a quick question. Did you receive your September notes? Have you received your September notes? Because most of my students say they haven't. Most of my students say they haven't received their September notes. Have you? Have you? Do you have a September notes with you? Because most they haven't. I don't know why. Maybe the printing team was late. Is late because it's because of the holiday. So there was some kind of delay in sending out the notes. Okay, do you guys have your notes? The September notes? Your Form 5 September notes, do you? Because many of my students didn't receive, so I have to kind of go slow this week because we have one more chapter remaining, which is our satellite chapter. Okay, so do you guys have the notes? Do you guys have the notes? Yes? Yes? Gabriel and Jella, do you guys have the notes? If you don't, please let me know because I need to adjust my speed. I need to maybe go slower. Okay, do you have the notes? Oh, you guys do, You guys have the notes ready. Okay, that's good. Okay, so guys, let's talk about 9.1 satellite. Okay, guys, this week I will go a bit slower. I'm sorry, even though you have the notes, because many of my students, they actually didn't have the notes, so I have to kind of match the speed between my physical and online class. So I do have to apologize that I go slow a bit today. All right. So guys, don't worry. Today it's gonna be a very relaxing class because this chapter 9. Okay, first of all, this chapter 9 is kind of a rubbish chapter if you ask me. Okay. Why do I say so? Because I'm not saying that this is not coming out in exam, but even if they do, it's gonna be like 2 or 3 objective questions. That's all, right? 2 or 3 objective questions for your exam, for your finals, for your SPM. So that's why I always tell my student, this chapter, don't bother. Okay, don't bother. I mean, you can study for fun lah, but don't bother. Okay, your favorite chapter because there's nothing to learn, right? It's stress free. Okay, so what is this chapter about? Okay, this chapter is about satellite. Okay, satellite. Okay, guys, do you know what is a satellite? Many of you, when I say satellite, you will think of something like this, right? Right? This is not just this is a satellite. Guys, what is a satellite? What is a satellite? Satellite is any object that orbits the Earth. Okay, that orbits the planet or stars. Right? Basically, planets lah. A satellite will go around a planet. Okay. Hi, Charlene. How are you? Wow, I haven't seen you in a while. How are you doing? We are in chapter 9. Do you have the notes? Do you have the notes? Okay. Oh yeah, Wi-Fi. Okay. So guys, we just started. Okay. So Charlene, don't you can join us. Okay, we just started. Right. So satellite is anything that goes around a planet, an object which orbits planets. Right. So in this definition, moon is a satellite. Right? Because we have 2 types of satellite. We have natural satellite and we have man-made satellite. What you are thinking of, this thing, is a man-made one. We made it and we put it up there, right? But moon is, a natural one because it goes around our Earth, right? And if you look at big planets, the bigger the planet is, the more satellite they have, right? Because the bigger the planet is, guys, imagine a very big planet like Jupiter. Jupiter is our big brother. He is the biggest planet. So Jupiter has 60 something satellites. We have one moon. That guy has 60 moons. Why? Because he is so big that he has very strong gravity. He has very strong gravity. He has 60 something moons. So maybe one of it is habitable. I don't know, right? Maybe we can live on one of it. Since we cannot live on Jupiter because Jupiter is so big and it's basically a gas. Jupiter is a gas planet, so there's no possible way we can live there. But hey, okay, so that's wishful thinking. Okay, anyway, so Moon is a natural satellite, and then we have many man-made satellites. Guys, do you know that Malaysia has 3 of our own satellites? And it's pretty impressive. Guys, it's pretty impressive. We have like 3 satellites. And it's all it's Miasat 1, Miasat 2, and Miasat 3. Okay, guys, I don't know whether you know this. We were among the first who put our satellite up there in Southeast Asia. Okay, that's pretty impressive, huh? That's pretty impressive, huh? Okay, so anyway, so we have 5 types of satellites here. We have 5 types of satellites here. Okay, 5 types of satellites here. So okay, we classify satellites based on their orbits. Okay, we classify satellites based on their orbits. All right, so can you see there's a LEO, there's a MEO, there's a HEO, there's a GSO, and there's a GEO. Okay, so guys, let me talk about this one by one. Okay, let me talk about this one by one. Okay, so let's talk about LEO. Okay, let's talk about LEO. Okay, LEO stands for low Earth orbit. Okay, LEO stands for low Earth orbit. Can? Okay, what does it mean by low Earth orbit? That means it's very close to Earth. Okay, can you see it's close to Earth? Guys, give me a second. I need to check something. Okay, guys, sorry about that. Okay, so let's continue. So what is a low Earth orbit? What is a low Earth orbit? Basically, it's a satellite that's closest to Earth. All right. So, okay, can I classify this into 2 groups? We have low, medium, and high. Can you see? We have low, medium, and high, right? So we have low Earth orbit, we have medium Earth orbit, and we have high Earth orbit. So it means Leo, MEO, and HEO, right? So as you can see from the name, Leo means it's very close to Earth, MEO means it's middle, high means HEO. And this HEO, right, it sounds kind of funny because Leo and GSO and GEO, they are kind of equally far. It's just that they are at different angle. Okay, so should I put HEO together with GSO and GEO, or should I put it together with Leo and MEO? I don't know, but HEO is kind of a middle ground. Do you guys get what I mean? You guys get what I mean? Okay, so what I'm trying to say here is Leo is like really close to Earth. MEO is like middle. HEO means like really far. Okay, same as GSO and GEO. Okay, I'll pay more attention to GEO. Okay, I'll pay more attention to GEO because GEO is how do I say this? It's really important because most of our satellite is GEO. Okay, anyway, let me talk about it one by one. Okay, let me go into this one by one. Okay, let's talk about Leo, shall we? Are you guys with me? Guys, I know this is boring stuff. You're like, sir, I learned this for what? I'm not gonna be an astronaut or something. And this maybe it doesn't concern you. I know, but hey, just as a general knowledge, okay, this is a good thing. Okay, this is a good general knowledge thing. Okay, okay, so anyway, let's talk about Leo first. Oh, sorry. Let's talk about Leo first. Okay, so let's talk about Leo. As you can see, Leo is really close to Earth. Is really close to Earth. And can you see the duration? Okay, guys, please write something down. Please write something down for me. The shorter the distance, the higher the speed of the satellite. Okay, the shorter the distance, that means the closer to Earth, the faster they spin. Okay, this is a very easy concept. Imagine you have a ball with a string attached. If the string is very long, can you see yourself swinging it around and it takes very long time to go around? It goes really slow. You get what I mean? Imagine a ball with a really long string. You have to swing it around really slow. But if the string is very short, you have to you can just swing it like this. Right? Right? So in this case, Leo goes around Earth really quickly. But Heo, GSO, and Geo, they go around Earth really slowly. Okay? They go around really slowly. Can you understand? Can you understand? So the shorter the distance, the higher the speed. That's what I'm trying to say here. Okay, so as you can see, low Earth orbit, our Leo, it goes around every 19 minutes. That means 1.5 hours it goes around Earth. That's really fast, right? One and a half hour it goes around. Okay, so as you can see, the velocity is really fast. It's really fast. It's like 7.6 kilometers per second. Wow, right? So 27,000 km per hour. Your car only goes 100 or 100. If it's really good, it's 200. This is 27,000. Okay, so you might say, sir, what goes so, what goes so close to Earth, right? Who is Leo? You have your spaceships, you have ISS, you have space telescope, and mobile phone. And mobile phone, what is mobile phone? Okay, guys, do you know what is your space station? Do you know what's an ISS? Do you know what's an ISS? Do you know what's the ISS? Yeah, NASA is part of it. You know ISS? Yes, the International Space Station. Do you know what is this? Do you know there are people living there? Like a few astronauts, they live there, and then time to time they will change the astronauts there. Basically, this is the space station floating up there, right? What is this there for? It's for research. Okay, right, guys. This ISS, it belongs to 5 space agency. These 5 space agency, they come together, they build this, right? Which is the Japan Space Agency, okay, Japan, Canada Space Agency. If I'm not mistaken, Japan one is called JAXA, and then you have Canada, and you have Europe. Okay, Euro, because Europe is a continent, so you have the Euro Space Agency, and of course NASA, the American Space Agency, and of course you have Roscosmos, which is Russia. Okay, so these 5, they come together, they build this, right? So you have 5 agencies of astronauts up there, right? You have Japan astronauts, you have Europe astronauts, you have Canada astronauts, okay, you have all these people up there to do research, okay? And yes, they go around Earth 90 minutes once, okay? So that means if you think about it, they see sunrise or sunset every 1.5 hours. Right? It's like day and night goes by really quickly because it goes around Earth in 90 minutes, right? And they basically have to live in zero gravity. Okay, basically they live in zero gravity. Okay, they have to eat space food. Guys, even them sleeping, they need to zip themselves to a wall. Right? If they don't do that, they'll just float around while they sleep. Okay, so the more you know, right? And oh yeah, speaking about this, right? Speaking about this, okay, let's talk about muscle. Okay, let's talk about muscle. You know, the more you use a muscle, the more you keep it. Do you understand? Like, let's say if you go to the gym, you train your muscle to be bigger, and then suddenly you stop doing, your muscle will shrink, right? This is what they do. You see, we are walking on Earth. We have gravity, isn't it? We have gravity, isn't it? So gravity is pulling on us. We are using our leg muscle every day without you knowing. That's why our legs work. We walk, okay? We can walk. Did you know that these astronauts, after 2 years leaving Earth, okay, after 2 years living in the ISS, when they reach Earth, when they come back down to Earth, they cannot walk. They will lose their leg muscle, right? Yes, they will fall. So they have to do physiotherapy, just like a person after accident. They have to do physiotherapy to train their leg muscles back to walk, right? So imagine the sacrifice you have to do, okay? And if you live in space under zero gravity, your heart gets worse too. Your heart gets weaker too. So yeah, it's a thing that you have to face lah, right? As an astronaut. Okay, but hey, you're doing something good for the mankind. So there you go, right? So this is your ISS, and they go really close to Earth, and as you can see, they are really close to Earth. You can kind of see Earth there. Yeah, exactly. So imagine you are up there and you're so homesick, you can see your house, but so close yet so far. Okay, not exactly close, but far, but it's not exactly far. So yeah, basically seeing Earth like right there, right? So this is your Leo. Okay, so guys, let's go to Meo. Let's go to Meo. Meo is a medium Earth orbit. They are quite a bit further, 20,000, 2,000 to 35,000. Okay, they go 12 to 24 hours around Earth. Okay, is this slightly slower already? And then the type of satellite, this is for your GPS. Okay, this is your ISS, this is your GPS. You know what's a GPS, right? You know what's a GPS. Guys, fun fact, this GPS was launched by the US originally for military purposes, right? GPS was originally made for military in the 80s, okay? Only in the 90s, late 90s to 2000, when we learn how to use GPS for navigation, then only they are open to the public. Last time, you have no access to this satellite, you have no device to access to it, only military they can do that. Okay, so whenever Waze, Google Map, whenever you switch it on, it is connecting you to this satellite. You know how that's really quick, isn't it? And they are usually very accurate. I mean, you have ordered Grab or Food Panda before, right? They can just pinpoint where your house is. They just know where you are, right? It's really, really accurate. So that's your Mayo. Okay, and we call it GPS lah. We call it GPS. The British, they call it sat nav. Did you know this? Did you know this? Right? Like we buy a car, we will say, oh, does this car come with GPS? The British, they don't say this. They say, does this come with sat nav? I was like, what the hell is a sat nav? Okay, oh, satellite navigation. So it's sat nav, right? Means very fast or very slow. Kavi, you tell me, if I can run 7 kilometers in 1 second, am I fast or am I slow? Then I convert it for you already. 27,000 kilometers per hour. Your car can go 200 if it's a really good car. Okay, a Ferrari or a Lamborghini can go 200, but this is 27,000 kilometers per hour. Imagine the speed, right? This is neck-breakingly fast. Okay, so but that's a very good question, Kavi. That's a very good question. I'm not an astronaut. I can't tell you. If I get to go to space, maybe I'll tell you. Okay. So anyway, so this is a Mio. Mio is for GPS. Okay, so let's look at HEO first. Okay, if you see GSO, GEO, and HEO, they are mostly for weather. GSO is for weather. GEO and HEO is for communication. Right? Communication, they go really far. So you see, GEO and HEO is communication. You see, both also communication. But I want you to pay special attention to GEO. GEO is what they ask. Right, guys, do you know what is GEO? It stands for geostationary orbit. Do you know what is stationary? Guys, what is the meaning of stationary? I think you learned this in last year's the velocity thing. What is stationary? What is stationary? No, that's not uniform. Stationary means not moving. Remember, a stationary object. Stationary. Okay, why do we call it geostationary orbit? Because geostationary, okay, geostationary, they are always on top of you. Okay, that means if let's say you have very good eyesight, you raise your you raise your head, you see that satellite there. Okay, you see a satellite. 5 hours later, you still see the same satellite. 10 hours later, you still see the same satellite. 24 hours later, you still see the same satellite. That means the satellite is following you. Correct? The satellite is following you. And if the satellite is following you, it is orbiting the same speed as Earth. Correct? Correct? I must follow the speed of Earth only to follow you. You get what I mean? Do you get what I mean? If I am okay, let's say you are rotating around. Let's say you are standing at the same place and you're rotating your body around. I have to run at the speed you rotate, only I can keep seeing your face. You understand? You understand? That means geostationary, they have to follow the speed of Earth. Okay, they have to follow the speed of Earth so that they can follow you. Okay, this is why Malaysia satellite like Miasat 1, Miasat 2, and Miasat 3, they are all geo because their job is to follow Malaysia. Malaysia satellite is to follow Malaysia so that we get Astro. Guys, do you have Astro at home? I don't, because I don't see Astro as a point. Okay, there's no point of having. Do you guys even watch TV anymore? Not really, isn't it? Okay, watching TV is like such an old thing. I mean, you do watch TV, but you watch Netflix and YouTube. Do you still watch like normal channels anymore? No, those are for boomers. I can't find spec without your spec. I understand your pain, Kavi. I'm such as well. Right. So guys, Miasat, the Astro satellite is to follow Malaysia so that we get coverage, so that we get Astro. Right? So they have to rotate the same speed as Earth just to follow us. That's why it's called geo. Okay, that's why it's called geo. So this geo, they orbit Earth at 0%, 0 degree. Okay, what's the difference between geo and GSO? GSO has an angle. Can you see? Can you see GSO has an angle? Okay, GSO has an angle. And HEO is at an even higher angle. So that's the difference. You see, GEO, GSO, HEO. GEO, GSO, HEO. So that's the difference. Okay, that's the difference. So GEO, our focus is still GEO because GEO is what we use for communication, for everything. Okay, so guys, I don't know whether you know this. Okay, I don't think you know this, but in 1996, we launched the first Miasat. Do you know how proud Malaysians were? Right? Because at 1996, imagine this, 30 years ago, close to 30 years ago, okay, which was 1996, we launched the first satellite. Okay, we launched the first satellite, and that was also the year Astro was born. Okay, Astro was born in 1996. That's when we launched Miasat, right? And we were amongst the first Southeast Asian country to do it. So imagine if you are Vietnam and Thailand and Singapore, and I think we were one of the first. Okay, imagine they look at us with envy, like wow, we launched our first satellite. Okay, Malaysian in the 90s, we were really good. Okay, I know you were not born in the era, you cannot relate, but in the 90s, Malaysia was really good. Okay, we were awesome at making money. Our GDP is really high. Okay, yeah, having food, yeah, maybe. Okay, so and people just know Malaysia as a very good country. Okay, guys, we were called the tiger of Southeast Asia. What do you think? Malaysia was known as the tiger of Southeast Asia. Okay, good times, good times. Okay, now we are just laughing stock, right? We are always on the news for the wrong reason. Okay, we lost our plane. Okay, corruption. We changed like 3 prime ministers in 5 years. Uh, Okay, highest COVID cases, shit like that, right? You see, we are on the news for the wrong reason. Okay, nowadays lah. Okay, 90s was really good. Okay, we built our first KLIA. We were one of the first country to have our. Hey guys, there were only 20 something countries with their own car brand. Malaysia was one of it. Okay, we launched Proton in the 90s. Yes, highest building. Yes, exactly. One of the most open-minded Islamic country. Okay, compared to like Syria and Iran. Really good. Okay, guys, we were really good. Malaysia was a really good country. Okay, now we were only for the wrong reason. Good times, good times. Okay. Anyway, so this is your geo. This is a geo. Okay, so they are mainly for communication. Whereas your GSO, this is for weather. This one you need to know. This one you need to know. So GSO is for weather. Okay. This guy kept lying to me every time. Okay, they say it will not rain tomorrow, and there you go. It's gonna rain. Okay. Hmm. Yeah, yeah, I agree too. I agree too, Kavi. I agree too, which is a very sad thing to see. Sad times to be a Malaysian, huh? Right, so there you go. These are the satellites that you should know, okay, which is your LEO for ISS, MEO for GPS, GEO, which is our communication one, GSO is for weather, and then HEO is also for communication. It's just that we don't use it a lot. Okay, you know it's remote sensing, guys? You know it's remote sensing? Remote sensing means I detect something from far. That means, okay, you know tsunami alert? How do they know it's tsunami? Because it's the remote sensing. Okay, satellite can sense tsunami. They can also sense like what? Earthquake, land shift, like landslide. How do they know? Because they have remote sensing. That's remote sensing for you. Okay, so HEO can do this. Okay, so speaking about Miasat, this one I have to let you know. So Malaysia, we launched this thing called the Miasat. You see our Miasat satellite system. Okay, we launched this in 1996. This is Miasat. There, you see, Miasat celebrates like 25 years of anniversary. Yeah. So this is ours. Okay, so this thing was mainly launched for Astro and Maxis. Astro and Maxis. Okay, so because the boss guys, did you know that the boss of Astro and Maxis, they belong to the same guy? Maxis and Astro, they belong to the same guy. Okay, which is Ananda Krishnan. You know who is he? You know who is he? The third or fourth richest man in Malaysia, Ananda Krishnan. Okay, so he owns Astro and Maxis as well. That's why you always see Maxis advertisement on Astro. Okay, and I don't know whether you know this. Maxis is the one of the most expensive telco in Malaysia because their lines are very good. Okay, I mean if you use if you use U Mobile, if you use DG, you know the line sucks, right? But Maxis you can kind of get it everywhere. Well, because they have a damn satellite to them, right? They even have all these cell towers to them because Maxis is really rich. That's why they charge you more. Because you get what you pay for. You pay more, then you get more line. Okay. Harvard University. Oh wow, I didn't know that. You're from Harvard. There, you see, Maxis, Usaha Tegas, and Astro. Hmm. Right, Ananda Krishnan. How old is he again? 85. Yikes. Okay. If I'm not mistaken, third or fourth richest in Malaysia currently. Currently, third or fourth. Okay. Guys, Ananda Krishna was kind of involved in this corruption thing in India because he tried to control communication in India. He tried to bribe India government to launch another satellite for him, which is not a very good thing. Okay, but I mean he's a businessman lah, so he's interested in making money. So not surprised. Okay. Anyhow, this I think this is actual knowledge that you should know lah, right? So the orbital shape. Okay, this orbital shape is really easy. Some satellite they go around Earth in a circle. Some go around Earth in elliptical. Elliptical means oval lah. Okay, like you see, Geo and Leo is circular. Because you see, okay, Leo is definitely circular because they go around. You see, they follow Earth. And then Geo is definitely circular. You might say, sir, Geo doesn't look circular to me, but imagine this is like roti canai, this is flat. Okay, but they go around us in a circle because they have to follow you. You know what's a compass? You know what's a compass? The compass you use to draw a circle. You imagine the sharp, the middle point, the sharp one is Earth, and you imagine the pencil point is your Geo. If this pencil point follows Earth around, it should be circle, isn't it? Am I making sense here? Am I making sense here? If this is if this is Earth, if this is Earth, and if this is Geo, and Geo just goes around Earth, because Earth goes around in a circle. So Geo, if they follow Earth, they have to follow in a circle as well. That's why Geo is definitely circular, right? But for Mio, Hio, and GSO, they are all elliptical. Okay, they're all elliptical. Are you okay with this? Guys, are you okay with this? So this is your orbital shape lah, huh? And of course, what is apogee and perigee? This one is not really important. Apogee is the far distance. If you are elliptical lah, that's the far distance away. That's the apogee. Okay, the perigee is the close distance away from Earth. The nearest is the perigee. Okay, perimeter. Remember. Okay, just remember the word perimeter, so they're near to you. So apogee is far from you. What's the function of geo? I said it about that. Geo is for communication. For astro, geo is astro. Geo is astro and maxis. Okay, that's about it, right? So guys, I'm just gonna talk about this today, right? I'm just gonna do some exercise today. I'm not gonna go fast because most of my students, they haven't got their notes yet, so I have to kind of go slow a bit, right? And there's no need for us to rush lah, because this is the last chapter already. And after this chapter, we are jumping into revision already. Guys, when this chapter finish, is when hell starts. Okay, I hate to fear monger, guys. I hate to fear monger, but that's what it is, right? So yeah, so we enjoy for now. Okay, we enjoy for now. Okay, let's go to our exercise, shall we? Let's go to page 6. As you can see, this chapter only has 5 pages. The note only has 5 pages. Okay, so we do this and then maybe we'll call it a day. I'm not gonna. Maybe I'll end the class early too, right? So let's look at this thing. Okay, so why is 2 and 4 pointing to the same thing? Okay, let's change 2 to this, shall we? Because it's now pointing to the same thing. Okay, 2 and 4 is pointing to the same thing. Okay, so let's look at number 1. Number 1 is this flat one, and it goes away very far from Earth. This is your geostationary. I'm just gonna write geo here. Okay, geo. And then what is number 2? 2 is very close to Earth, so this is Leo. Okay, Leo. And then number 3, this goes very high angle. This is Hale. Okay, Hale. And of course, number 4 is definitely male because they're like halfway, not too far, not too near. Okay, you must say, sir, where's GSO? If there's a GSO, it will definitely look like this. At an angle. So this is your GO. Sorry, GSO. It's not, they didn't ask here, so yeah, keep it that way. Right, so B, name the correct satellite or orbit. Satellites are located at a height of 160 to 2,000 kilometers. Can you see this is really close? So this is definitely your Leo. Okay, very close. Next, the satellites are above Earth's equator and taking 23.93 hours to complete an orbit. That means 24 hours lah. That means they follow Earth. Okay, that means they follow Earth. So this is definitely your geo. Because Earth goes 24 hours around, they also go 24 hours around. So they follow Earth. You get what I mean, right? You get what I mean, right? Earth takes 24 hours to go one round, so our Miasat will also take 24 hours to go one round, just to follow us. Okay, the satellites are highly elliptical shape orbit. Highly elliptical. What does it mean by highly elliptical? But from what I know, it could be here. Highly. That means do they go very high? I don't know. So this is your here. Next, C. What is the difference between GEO and GSO orbit? Okay, very good question. So GEO is circular, but GSO is elliptical. Okay, or you can even say GEO is 0 degrees in whereas your GSO is inclined. Okay, that means GEO is flat, but GSO is like an angle. And then GEO is even higher angle. Okay, guys, can you follow this? Just a sad thing, this will never come out in subjective, never come out in paper 2. It just doesn't, right? It's all in objective. So you can tembak to your heart's content. I really don't care. Right? Then so we learn this for what? I don't know. I don't know why our Ministry of Education decided to put this chapter. Maybe it's just to chill you guys down a bit so that you don't get so tension learning all these technical chapters. Right? So next, we have low Earth orbit LEO. Orbital height is 180 to 2000 kilometers. Shape is circular. Wanted to make it another. Also, you wish there's another chapter like this. Okay. Guys, did you know that? Okay. General info, general knowledge. Do you know did you know Malaysia had our first astronaut? You know, we sent a guy to space. Did you know we sent a guy to space? You know who's the guy's name? I mean, the note says 180 though. So we follow 180 lah. Did you know we sent a guy to space? Dato Sheikh Muzaffar Shukor. Mustafa. What's his name again? Our first astronaut. Was it Muzaffar or Muzaffar Shukor? Yes, that's him. That's our first astronaut. Okay. Now we spent a lot of money sending him to space. It was like what, 10, 15 years ago? Quite long ago. Yeah. Right there. He launched to the International Space Station aboard Soyuz. Soyuz is a Russian spaceship lah. On 2007. Wow, damn. Yeah, it looks very handsome, right? 2007. 2007. Wow, how long was 2007 ago? 16 years? Yeah, 16 years. Wow, shit. Your age. 17, 16, whatever. Right, so Mayo. Okay, Mayo is 2000 to 37,000. Not the exact figure lah, okay? It's 37 blah 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 thousand. Oh, 35, sorry. Whatever. Okay. They will not ask this in exam, just to let you know. So this is elliptical. I'm just gonna write ellip here. Here is 35,000 and above. Sorry, more than 35,000. So this is also elliptical. GSO, same as this. More than 35,000. Also elliptical. Geo, also same thing. But this is circular. So we have Leo and Geo being circular. Okay, that's all. Okay, so next, number 3. Match the types of orbit to the kind of satellite that are suitable. Okay, we look at the first one. Hubble Space Telescope. You know what's a space telescope? Oh, I haven't shown you now. Okay, space telescope is a Leo, by the way. Space telescope. It sounds like what it says lah. Okay, it's a telescope, but it's in space. They are there to observe things, right? To see space weather, to see, you know what is solar flare? to observe the sun, to see whether there's any crazy solar activity, any solar wind, solar flare, or coronal mass eruption. Do you know remember what is a CME? Big bang on a big boom on the sun, which can affect our communication. Basically to see things around lah. Okay. So there's a space telescope. So this is definitely a Leo. Right? Weather satellite is definitely a geosynchronous, which is a GSO. No, not that. Right. So basically they observe the sun lah, see if the sun goes crazy. Right. Next, communication. Okay, communication has so many. Communication, but generally is geo lah. I mean, it can be HEO as well, but generally it's geo. High Earth orbit, that's your imaging. Imaging, you know, remote sensing, just now I say, remote sensing, that's your HEO. Navigation is MEO, which is your GPS. Remote sensing, yeah, that's your HEO. Space station, LEO. Right? Don't worry, this will never come out. Never ever has it come out in SPM. I mean, in this form, where you join the lines, yeah, pretty impossible. Okay, so let's look at number 4. So there's the orbits of two satellites, which is A and B. So A is definitely geo. I mean, the full answer is geostationary. Whereas B, this is called geosynchronous, which is GSO, right? Don't write short form, please write in the full name if this, okay, this is not coming out for exam, okay, so don't care. One similarity between two satellites, okay, they are the same distance from Earth. Okay, same distance from Earth. Oh, each one I'm writing from Earth. So see, what is the characteristic of satellite A when viewed by an observer who's located on the surface of the Earth? Okay, when you see A, like I said, it's always on top of you. Okay, it is always following the observer, right? You go around like this, they'll just follow you around. Always following you, like the moon. So D, what is the use of satellite A for communication? Right? State one example of this type of satellite which is owned by Malaysia. Yeah, that's your Miasat. Depends on which country lah. If that satellite belongs to Singapore, then it will follow Singapore. If it's for Thailand, then it will follow Thailand. Every country has one. I think. Should be lah. Right? Every country has one. So we have like, guys, there are thousands of satellites going around Earth. Do you know that? It's like flies going around an ice cream. We have thousands of satellites going around Earth, right? But here's the amazing thing. They won't ever run into each other. Pretty impossible. All right. And that, guys, there are some satellites that is like useless one, right? Some companies, they put it up there, then they couldn't maintain it. They just leave it there. So those satellites are like abandoned satellite. Is there, right? It's like space rubbish. Okay. Greeny, huh? Who? Who came to KL? Aliens. Did they? Come on. It's not true. Okay. So name the shapes. So Q, it's circular. R is elliptical. Okay, so you have a perigee and apogee. Which position is furthest? Furthest is apogee. Nearest is perigee. Okay. If a satellite is at the perigee, what is the effect of Earth's gravitational force on it? Okay, it has stronger gravitational force. Okay. Oh, was it? I didn't know. I didn't know. Okay, why is it stronger? Because the closer to Earth, the stronger the gravitational force. Okay, the closer to Earth, the harder, the stronger they pull me. Earth pull me. Makes sense, right? Because when you're further away, Earth cannot pull you, so you are out of space. You are gone into space. Okay, you get what I mean? Okay, so guys, I think I'm going to stop here because the rest of it is just repetitive question already. Okay, so next week I'm going to tell how do we launch a satellite into space. Okay, and I think I will finish this by next week. I'm not sure. Maybe I will, maybe I won't. I don't know. Okay, but yeah, this is basically a very mindless and useless, shall I say, chapter. Okay, asking for the Earth's gravitational force. Yeah, correct. What is the effect of Earth gravitational force on it? On it, stronger lah, stronger lah. They act stronger on it, right? Okay. So guys, do you have any question? Do you have any question? If no, then I'll let you go early. I'll let you go early. There's no need for me to blab about satellites for another 10 minutes. So I'll let you go early lah. Okay, I'll let you rest before we go for revision. Okay, that's gonna kill you. But hey, that's for another time. Okay, so guys, I hope you have a wonderful Wednesday. I hope you had your holiday. I hope you rested well during the holidays. I hope this week is for you to kind of, get yourself back up because next week, I hope you come back with more energy and get ready for our revision. Okay, so guys, I will see you the same time next Wednesday. Okay, so do take care. I will see you. Okay, you too, Kavi, you too. I'll see you soon. Okay, so see you, take care, and bye-bye.